Today's webinar at the TUMIVolt Charging Station. This is our webinar series which we're running in the project TUMIVolt, funded by the German Federal Ministry for Economic Cooperation and Development. And today we're very excited to be sharing with you a webinar with a total of 3 experts already on the topic of technology neutrality, zero emission bus selection. And what we've prepared for you today are 3 inputs, one of which is the first input given by Dr. Carl-Friedrich Elmer, who will focus on technology neutrality and just kind of dive us into the question, what does this term actually mean, and what are we talking about when we say that we want to reach technology neutrality. And then afterwards we'll have a very short Q&A for him, because he has to leave at the end of the session a bit earlier probably. So if there's any burning questions that you need to have answered right at the beginning, feel free to just post them in the chat or in the questions bar on your right on the dashboard, so we can make sure that we address Dr. Elmer just in time before he has to head out. And then we'll go on to our 2 expert presentations from our colleagues at the ifeu, and they'll be talking about zero emission bus promotion as well as the selection of the appropriate technologies. And we'll finish off today with a Q&A, of course, with all the questions that we've compiled over the following hour. So briefly giving you an idea of what we'll be talking about after the first kickoff input on technology neutrality. As we said, we will have a short input focusing on what are the push and pull factors that actually lead cities to implement and purchase electric buses. We'll take a look at how Germany is promoting electric buses. And finally, we will also dive into zero emission bus technologies and their selection criteria. So we're covering quite a wide range of factors for you today. And the colleagues doing this actually are, as I said, Dr. Carl-Friedrich Elmer from Agora Verkehrswende. He's project leader for transport economics, and he's going to kind of help us into this topic that we're discussing today. Then we'll hand over to Mr. Dominik Räder. He's a research associate at ifeu, and he focuses mainly on transport emission modeling and inventories, and environmental policies and roadmaps, as well as city-level GHG mitigation strategies. And finally, we also have Mr. Fabian Bergk from ifeu with us today. He is also a research associate at ifeu, and he focuses on transport emission modeling and inventories, environmental policies and roadmaps, as well as national and community level scenario analysis and development of GHG mitigation strategies. So very excited for these inputs for you today. I hope you're all ready to post any questions in the chat or the questions bar. If there's any other questions during the webinar, feel free to let us know. I'm Lina. I work with the TUMI initiative, as well as my colleague Rohan Modi, who is a German Chancellor Fellow, will be guiding you through this webinar and doing the Q&A with you at the end. So with that said, we'll jump into the first presentations, for which I just quickly have to change the presentation because we have it in a different format. So please bear with me as we go over here. And then I'd like to hand over the microphone to Mr. Elmer, please.
Yes, thank you, Lina. Thank you very much for the kind introduction. So I would like not to dive too much into the specific topic of buses and which buses are most appropriate for transforming public transport in cities, but rather going back to the general question, which regulatory approach is best suited for steering the technological transformation in general. So I want to elucidate a little bit on the different terms: technology neutrality, specificity, and technology openness. So what are the differences, how to define these terms, and how they interact, and what are the implications for actual transport policy? So could you please switch to the next slide? The general background is, so there's no question we need new drivetrains, new technologies in the transport sector to achieve our climate targets. So for instance, in Germany, it's currently to reduce emissions by 42% compared to now, and also compared to 1990, but probably it's going to be more with regard to Green New Deal and the stricter targets that will come on the European level for emission reductions. So there's no question about the general goal of getting new technologies, but the question is, how do we get there? So which should be the regulatory approach? And so believers in markets, so mainly from, I'd say, rather industry-friendly liberal parties and also from the industry, often call for a market-driven or technology-neutral or technology-open policy approach in order to let the technologies compete against each other, and hoping then that finally the greenhouse gas reductions will be delivered by those technologies which can do that in the most cost-effective way. So they fully trust into the cost-reducing nature of competition. And in this debate, two terms are often used widely synonymous. So that is the term technology neutral and technology open. In German, Technologieneutralität or Technologieneutral or Technologie offen. So it's a little bit hard to translate it into English because they are not that common in the English debate, but we hope to introduce them a little bit more into the English debate. So could you please go to the next slide? So far, they're used widely synonym, but according to a study that we have done together with ifeu, so we have two also here, and the UFC Leipzig, we tried to get more clarification into the meaning of those different terms. So according to the definitions we use in the study and in the aftermath, it's technology neutrality is not the same as technology openness. Technology neutrality is a characteristic of regulatory invention. That means we treat all technologies exactly the same, irrespective of maybe special needs of a certain technology, of their specific properties. So we have one regulatory goal, and that is the reduction of greenhouse gas emissions. And all technologies are subject to the same regulatory approach. And that should treat all technologies exactly the same. Typically, the policy preferred by those proponents of technology neutrality is a uniform carbon price. So we have to pay a certain amount of money for each ton CO2 that is emitted, and that applies to all technologies, and that will drive the market to the most cost-efficient mitigation technologies. On the other side, technology specificity, sorry, I sometimes struggle with the word. It's different because there are special support for some technologies. So it is asserted that some technologies do need, especially in the beginning when they're coming into the market, some specific support, and that not all technologies are equal. And in order to get those into the market, which are the most efficient in the long term, we need special support in the beginning. Next slide, please. And now both approaches come down to the term of technology openness. So technology openness doesn't apply to the regulatory invention, but to the regulatory environment. So, for instance, if we look at the market for cars, but also for buses or for trucks, we're talking about different decision spaces, and the decision space is deemed technology open if it is completely undistorted. Apart from that distortion, we want to correct. So that is greenhouse gas emissions. We want to reduce the greenhouse gas emissions, and so we apply a price. But apart from that, there are no further distortions in the market. But that would lead to technology neutrality to be cost efficient. But but we really have in reality, or we would have in reality, technology openness only if there are no other distortions and if all decision makers do take all private and social costs into account when making their decisions. But if we don't have that case, that there are no further distortions, but actually there are those further imperfections in the markets, then technology neutrality will not bring along the most cost-efficient results, because then we have a twofold or manifold distorted decision field, and so it's not open anymore. So I'm pretty sure we will get some questions after my presentation on that, because it's highly economical and somehow complicated matter, and to differentiate between these two approaches. So I will go on, and I'm happy to answer your questions afterwards. And as I said, technology neutral policy. So next slide, please. Sorry for that. Alina, could you go to the next slide, please?
Sorry, my bad.
As I said, technology neutral policies that treat all technologies the same, be it battery electric or fuel cell electric buses and cars and trucks and whatsoever, will bring along minimal cost solution for achieving a given greenhouse gas target, only if they encounter this kind of perfectly technology open decision space. In real life climate politics, however, you hardly ever find any decision space that is undistorted. But in reality, there are a number of different market imperfections. So just to name a few: logins and path dependencies, because some technologies have already undergone learning curve, so that their costs have went down significantly in the past, while other technologies are still at the beginning of their learning curve. So they are currently much more expensive, but in the long run, their costs will go down. Decision makers don't act based on perfect information. And to correct those distortions, we may need technology-specific regulations. And I think I will skip that for a moment. So, or I will just briefly give you a short explanation. So, having a distorted decision field, then technology-specific regulations may be warranted if they're designed well. Technology-neutral solutions are only warranted if there's an undistorted decision field, but we hardly have that. And then in reality, it often comes down. Oh, sorry. I again forgot to change the slide, please. So that means I won't go further into details, but if we have a distorted decision field, we need policies that can really address those distortions to be efficient. But technology-neutral policy will hardly ever be efficient, but technology-specific policies will only be a good solution if it's well designed. So, next slide, please. Oh, pardon, now I have a slight technology problem. Also, technology-specific policies that address and support a specific technology may be warranted if we have further policy goals, for instance, reducing local pollution. Then we don't want to have combustion engines anymore. If we want to foster a specific policy for industry policy reasons, because we want to export it. And there's a rationale for addressing policy technologies specifically, but as I said before, it has to be well done to achieve our goal in a cost-effective way. Next slide, please. So in reality, what we need is to have a policy mix which also encompasses technology-neutral approaches like a carbon price. We definitely need a carbon price, but we also need specific policies that address those obstacles and barriers that new technologies, especially in the beginning of their learning curve and during their ramp-up phase, face. So that means, for instance, that we need to support the infrastructure build-up of new technologies, because there we have a hand-egg problem. We have those kind of network effects. First, we need a critical mass of new vehicles that we have a self-sustaining infrastructure development, and also to get the costs down in the beginning. It may be well warranted to have temporary purchase incentives to get a certain number of vehicles on the road to reduce their costs. So in reality, it's not either or. So it will hardly ever be, do we have a totally technology specific or a totally technology neutral approach, but rather something in the middle, and which concrete policies, which concrete steps do we take. But it's often more a kind of ideological debate, but in practice it's always somewhere in between, and the ideological debate about technology neutrality often distracts from the concrete challenges, from the actual challenges we have in designing policies in detail that really work for the specific field you're looking at. And in our study, next slide please, we look at trucks and cars, but we will definitely have the same challenges for buses. And yeah, I'm happy to hear how Dominik and Fabian address those challenges for the bus sector. Thank you, and sorry for going very fast through it, and maybe it won't always be easy to understand. And still, I think I used up my time totally, and even maybe some minutes more. Sorry for that.
Thank you so much, Dr. Elmer. That was a very concise input into a very complex topic. So I'm wondering, Rohan, who's monitoring the questions and the chat, if there are any questions on this presentation, I would say in the interest of time, if there's one or two questions, let's allow them now so we can make sure they can be answered. If not, we'll go on to the other two presentations. Rohan, what is this?
Yes, so I think the very much expected question we hear from the chat is, they say, considering the current situation, which is having the biggest external distortion, that's COVID-19, many developing countries have a cash-strapped situation. In this situation, Dr. Elmer, could you please suggest some ways in which how these countries could develop a technology neutral approach? Because they say the funding from the governments is mostly tied into certain specific technology, and they do not have much money to spend on all the technologies. Yes.
So that's always a difficult question, and I'm not that much into buses. So for instance, in the segment of trucks, you don't exactly know what will be the best technology in the long run, or will it be a mix of different technologies? How do you deal with limited funds? Which technology do you dedicate them? So for me, it's hard to find a general answer. So because it depends on on the precise vehicle segment and technologies there. First of all, I'd say try to get as much money as you can from the dirty technologies, and if you can do it in a socially equitable manner, so also in developing countries, maybe you can tax the rich as much as possible on their use of carbon intensive resources like high emitting cars. And then maybe in the bus segment, maybe we'll learn more later, then probably it's more clear which technology is suitable, and then focus the money on that technology. But I'm not that much into the technology of buses. So which technology I would give the question back to Fabian and Dominik.
Well, in that case, I think maybe we'll actually head over to the first presentation on that topic, and then compile more of the questions for after those presentations. So allow me to just jump back here into our main presentation, and we will go on with our first presentation by Dominik Räder. I am just handing you control of the mouse, so you're able to switch the slides by yourself, and then the stage is all yours, Dominik, to take us through your presentation.
Thank you, Lena. Before I start, I also would like to thank TUMIVolt for the invitation and say welcome to everyone. My name is Dominik Räder. I studied mechanical engineering and transport engineering, and I'm working for the Institute for Energy and Environmental Research since 2018. I will cover the first 2 points of today's presentation from ifeu, and then hand over to Fabian Bergk, who will cover the third point. In the first slide, I would like to present some push and pull factors which we think will accelerate the market uptake of electric buses in Europe. And during the second part of the presentation, we will then take a closer look at the current electric bus supporting and funding programs in Germany. And closely linked to that, I would like to give a brief overview of the actual electric bus fleet in Germany and some additional supporting activities for the market uptake of e-buses in Germany. After that, Fabian Bergk will present the actual status of the relevant bus technologies and further on approaches for selecting the most suitable technology. So let's start with the push factors. As Mr. Elmer already told, there are GHG emission targets which will foster the market uptake of electric buses. On EU level, the European Commission sets greenhouse gas emission targets in order to address climate change. And the target until 2030 is to reduce the GHG emissions of all emitting sectors by minus 40% in comparison to 1990. And in addition to that, there are currently discussions ongoing regarding the implementation of more ambitious reduction targets for 2030. Parallel to the EU targets, Germany also has defined specific greenhouse gas emission reduction targets within the German transport sector. The GHG emissions have to be lowered or reduced by at least 40% until 2030 when compared to 1990. What that means, we can see on the right hand side. There you can see the GHG emission development in the transport sector in Germany from 1990 until today, and the target for 2030. And this graph shows that this target is quite ambitious, and it will be a challenge to achieve the 2030 GHG reduction target in Germany within the next 10 years. Yeah. And besides the GHG emission targets, there are further regulations which directly or indirectly influence the market uptake of e-buses. For example, the Alternative Fuels Infrastructure Directive, which sets the framework for the development of infrastructure for alternative fuels. For example, charging stations for electric cars and buses in Europe. Another regulation is the Renewable Energy Directive, which sets quotas for the use of renewable energy within the transport sector. And probably, the most relevant or most important directive in terms of e-bus development in Europe is the Clean Vehicles Directive, which we will take a closer look at in the next slides. The last push factor are restricted areas caused by air pollution and noise, which probably will become more relevant in the future, at least in Germany. In some countries, they are relevant at the moment, especially with regard to air pollution and noise. E-buses offer significant advantages in comparison to conventional buses. So as mentioned before, the Clean Vehicles Directive is a very important instrument to foster e-bus market uptake in Europe. And well, let's take a closer look at the directive. The CVD is an EU regulation which is in force since August 2019, and it sets minimum quotas for public bus procurement and has to be implemented into a national law until the August of 2021. In Germany, the Ministry of Transport coordinates this implementation process, and within the regulation, the EU explicitly mentions national financial support to assist this market uptake of e-buses. And as you can see in this graph below, the Clean Vehicles Directive is divided in 2 phases. The first phase starts in August 2021 and is valid until the end of 2025. The second phase starts in 2026 and is valid until 2030. Within every phase, the EU has defined specific shares for zero-emission buses, so-called zero-emission buses, clean buses, and the zero-emission buses are battery electric buses, fuel cell buses, and trolley buses. And the clean buses, on the other hand, are hybrid buses, gas buses, LPG, LNG, and bio as well as syn-fuel buses. And there is also a certain amount with no requirements. And when we take a look at the phases, in the first phase, a share of at least 45% of all new buses have to be zero-emission buses and clean buses. And in addition to that, at least 50% of these buses have to be zero-emission buses. In the second phase, the share will increase to 65%, and the same as before in the first phase, at least 50% of these buses have to be zero-emission buses. So with this new bus procurement requirements from the EU has implemented a very strong instrument which will foster the market ramp up of zero buses and clean buses. And besides these push factors, there are also pull factors. The first factor on this slide says electric public transport enables sustainable mobility. This means that for the transition, towards a fossil-free and sustainable public transport, e-buses, at least operated with renewable energies, are a key technology and play an important role on this path to carbon neutrality. And a second further pull factor are funding programs and scale effects, which will lower the bus prices and therefore help to enable competitive e-bus operation, at least when compared to conventional diesel buses. Because today electric buses cost more than twice as much when compared to conventional buses. This means in the early stage of the e-bus development, funding is very important and essential in order to get close to the cost parity between electric buses and diesel buses. This said, of course, the gap between those two technologies, or even more technologies, depends on how the funding programs are set up. But nevertheless, funding programs and scale effects will enable e-buses to be more competitive in terms of the total costs of ownership. Besides the economic aspects of the e-buses, also the technical maturity and the availability are important, other important aspects. And we think that with each of the new bus generations, buses will get more mature and more reliable. In addition to that, the number of buses available on the market will increase or increases over time, over the last years. Today, almost all well-known European bus manufacturers offer electric buses or bus models within their portfolio. And furthermore, as battery technology, for example, will further improve during the next years, this will make e-buses a more attractive options for bus operators. These three pull factors are just a few examples for pull factors. Nevertheless, many cities are aware of these advantages of e-buses and have declared that they will procure e-buses in the future. In addition to that, many cities have set themselves specific goals regarding the future of the bus operation. For this presentation, I've picked some goals from a few cities in Germany, but the actual number of cities which have set goals is even higher and is likely to grow over the next month and years. In Germany, for example, there are two cities, Berlin and Heidelberg, where the ifeu is located at, have joined the C40 Cities initiative, and the member cities of the initiative agreed to procure zero-emission buses only from 2025 on. And another example in Germany is the e-bus strategy from Hamburg. Hamburg plans to procure zero-emission buses only from 2020 on, and has set the goal to operate zero-emission buses only until 2030. Oops. So in order to support bus operators financially, Germany's federal government has implemented some bus-related funding programs. In this slide, you can see the bus-related funding programs. It has to be mentioned that the first three programs are not only focusing on buses, they are also cover a broad range of other vehicle types and technologies. For example, cars and trucks can be funded with these programs. The e-mobility, electromobility on site, for example, covers funding for research and development projects, as well as pilot programs and e-mobility concepts. And within these projects, charging infrastructure and buses can be supported financially. And the National Innovation Program Hydrogen and Fuel Cell Technology, as the name may imply, mainly focuses on the development and market uptake of hydrogen cars, as well as infrastructure. And as mentioned before, the first three programs in this table, in this list, were not specifically designed or set up for funding large e-bus fleets, only for research and development, pilot projects, and e-mobility concepts. But with Germany's grant program for funding electric buses, this program, on the other hand, is the first and only program to date with a special focus on e-bus procurement. And within this program, buses as well as the required infrastructure can be funded. In the next slide, we will take a closer look on this program. So this funding program is in force since 2018, and in a first phase it is valid until the end of 2021. However, it is very likely to go into a second phase beyond 2021. The initial goal of this program was to fund at least 100 to 150 new buses, including the required infrastructure, charging infrastructure. And the initial funding was planned with a total amount of 350 million euros. But in January 2020, the EU agreed for additional funding of 300 million euros. The program is set up to cover all the additional, or not all, but a certain amount of the additional costs when compared to the procurement of conventional buses. For battery electric buses, for example, additional costs up to 80% in comparison to conventional diesel buses were covered. And for plug-in hybrids, the amount is 40%. As I mentioned before, charging infrastructure is also covered by this program with 40% of the costs. And an important factor is that this funding program can also be combined with further federal state funding programs. Here is an example of one of the federal state funding programs from Baden-Württemberg. The Ministry of Transport in Baden-Württemberg supports the procurement of fuel cell electric buses, battery electric buses, and hybrids, plug-in hybrids and other hybrids, with 40% of the additional costs, also compared to conventional buses. But the total amount, I have to mention, is limited to a certain amount, which is divided between or is limited for every technology. So on to the next slide. With the before mentioned funding programs in Germany in place, maybe the question arises how the e-bus vehicle stock in Germany developed over the last years. In the map on the left-hand side, you can see an overview of the electric buses which are currently in operation in Germany. When looking at the e-bus vehicle stock development and technology shares in Germany, one can see that the number of e-buses in Germany increased over the last years, especially over the last year or during 2020. The number strongly increased. One reason, of course, is Germany's grant funding program. However, the total number of battery electric buses in operation is still very limited, with about 400 buses. And you also can see that the bus fleet is dominated by hybrid buses, and only a few fuel cell electric buses are in operation in Germany. When comparing these numbers with the total fleet of public buses in Germany, with around 33,000 public buses in operation, then this means a share of only about 4%. So this means that the e-bus development is still in an early stage in Germany. But however, there are many e-bus projects in the pipeline for this and next year. So the number of buses will increase over the next years. and to evaluate the ongoing projects and market situation development, as well as to further accelerate the market ramp up. The Ministry of Transport and the Ministry of Environment have established 2 supporting instruments. One instrument is the working group Innovative Buses, which is a platform where all relevant stakeholders come together. These stakeholders are, for example, federal ministries, transport operators, the Association of German Transport Operators, OEMs, oh, there's a mistake, OEMs, and organizations from science and consulting. The overall goal of this working group is to promote and accelerate the integration of innovative buses or technologies, which means actually electric buses through knowledge exchange between the large number of people involved. And the second instrument is the accompanying research program for Germany's grant program for funding electric buses. And the goal of this research program, the goal is to analyze the e-bus market and the development of future perspectives for e-buses. And another important goal is to evaluate the bus operation within the funded projects and to evaluate the general effectiveness of the current funding program. This research program is divided into 4 different modules. In the first module, the national and international bus market is assessed and analyzed. In the second module, data from the funded projects, for example, operating data such as operating days or downtimes or specific energy consumption were analyzed. And in a third step, the effects of the funding program will be analyzed, and also policy recommendations will be drawn. Some of these results from the research program will be published, and there also will be a close exchange between stakeholders and the ministries. So there's an exchange between the working group and also the research program. So far from my side. Now I would like to say thank you for your attention and hand over to Fabian.
Thank you so much, Dominik. Fabian, I've given you control of the mouse. Hopefully it's already letting you switch forward, otherwise it might take a second to adjust, as we've learned before.
Okay, yes, I tried to take it. Let's see if it's working.
Probably like the test before, it's gonna take just a few seconds and then we're able to carry on.
Well, anyway, I can just start talking, and otherwise I will just tell you to go to the next slides.
Okay.
Well, so I start with this slide then anyway, because nothing is happening for now. Now it's working. So I hope this was my mouse click. So I would like to tell you about already 4 years ago in 2016, in the framework of the mobility and fuel strategy. This is a really broad project, or this was a really broad project, like the overall strategy, which includes also ships and trains and everyday mobility. So it was really like just a part of this whole strategy, and it was a really short project, and I was really happy to do this together with the Dr. Ralph Pütz from Belicon. And at that time, it was about the potential of in-motion charging buses. So in German, this is the Oberleitungshybridbus, and it was like the picture you can see there. It's like from that time, and it was like the first one of that kind. And what is it? Because this is like a heard of in motion charging or IMC bus before I did this study. So this is basically a trolley bus which has a battery, so it can like disconnect from the catenary lines and then run around the city freely, but it has just a limited battery capacity, so it needs to dock onto the catenary lines like after 10 kilometers or 15 kilometers. Which means like you just need like something like 50% of the line you want to electrify with this like expensive infrastructure, and you can go around if there are some obstacles, but on the other hand you still need this infrastructure. But it was really an interesting thing at that time, and but I think which is more interesting for nowadays is the approach we developed for the bus technologies of this different buses, and because in this framework it was like for whole Germany, it was like more a generic question we had. It was not like a specific use case. So I actually, because I don't know like the background you have, but if you have specific use case, I think this is even better to use, and you can like what do you need for the buses. But let's start with this, like what we did, because it's generic. Also, you get some insights, and also I'm really happy to hear from Dr. Elmer afterwards if this is a technology open or a technology neutral approach, what he will say to that. So I'm going to the next slide. Yes, so the scope of the study was to do a comparison between different zero-emission bus technologies. So in that we looked at the trolley buses. Here you have the conventional trolley bus and the in-motion charger, like what I said just a few seconds ago. Then you have the battery electric buses, and here two technologies actually in place. So the one is the depot charging, so as we call it, the overnight charger, and the other one is the opportunity charger, which has like smaller battery but a high power battery, which can be charged really quickly, for example at the end of the line. So yeah, it's like charged frequently, while the other one is just charged in the night. And the second zero-emission bus technology we were looking at is the fuel cell buses. And here also you have two different technologies. The one is a fuel cell hybrid, which has a small battery, and the battery is basically just giving the power to the engine. And you also have the fuel cell range extender, which has a bigger battery. And here the fuel cell is much smaller and the battery is much bigger. So the usage of the fuel cell is more to expand the range of the whole vehicle. It also runs like the whole time on the batteries. So as I said, we were looking like for a generic use case, which in that case means, okay, we were looking at what is really frequent in Germany, which are 80-meter buses. This is like if you see our standard articulated buses, and we defined standard technology values for all these technologies. For example, for the trolleybus, for the motion 20 kilowatt hours battery, and for the battery electric overnight charger 400 kilowatt hours. for the opportunity charger 150. And I don't know why. Oh yeah, now that it's coming. And moreover, for the fuel cell hybrid, 160 kilowatt fuel cell and 30 kilowatt hours battery. And for the range extender, 30 kilowatt fuel cell and 150 kilowatt hour battery. So because this was also already in 2016, there were like one thing we didn't anticipate so well. So in that time, we thought like the fuel cell hybrid will be like the more ready technology, and it will be the one which will be the more popular. But actually, as we see now, I think the things are tending more into using the fuel cell as the range extender. So anyway, we chose like this 4 technologies for the comparison you see into the red rectangle, which are also buses, like let's say the trolley buses, they have available the battery electric buses also, but most OEMs. So the market is much wider for the smaller buses, for the standard buses, but there are articulated battery electric buses too. And the fuel cell buses, they're kind of available, but it's more like you have long, like kind of some time between if you order one and you really get one. This is more like maybe you get one in 2021 or 2022. So yeah, so there's still like battery electric buses and trolley buses are a little bit more available than fuel cell buses. On the next slide, yes, so we did this comparison for different technologies, and this is for sure. So I just said about the scope. It's like 0 emission buses for 18-meter buses, and also it's like in the city use case bus line, which there's like a big bus going like every 5 minutes or every 7.5 minutes or every 10 minutes. And what we want to compare all these technologies is, for one, the environmental performance, and for the other hand, the economic performance. And for the environmental performance, we have considered different parameters. As we say, like, we call them 0 emission buses, but in reality, there's nothing like a 0 emission bus. This is just like they have 0 tailpipe emissions, but we at ifeu, we always look at the like from a life cycle perspective. So we not just see the tailpipe emissions, we see like the whole emissions during the use phase, including upstream emissions, but also the emissions which are emitted during production and also for the extraction of the raw material. And we looked at, like, especially at the greenhouse gas emissions from all these phases to compare the bus technologies with each other. How we did this, because we had this advantage, like we were looking at technologies which were like in 2016 kind of available, but not really there. But we know a lot about from scientific literature, from contacts to the OEMs, what will be like the specific technology criterias. And also we know from the EcoInvent 3.1 database, the material upstream emissions. And we did like a component model. So for example, we had some emissions per kilowatt hours of battery, and then we just scaled it up for each different bus technology. Or we have some emissions for the electric drive, or for the fuel cell, or for the hydrogen tank. For the usage, was I that? I don't know. For the usage phase, we have the exhaust pollutants with the ifeu data bank, but this is just relevant for the a reference point for the diesel bus. What is more interesting is that we had the traction energy demand from measurements we did together with the Belicon GmbH, which did these measurements in really a lot of different pilot projects all over Europe, and I could say like all in the world, like almost. And so we got like really a big set of data for the energy usage of the different buses. And then also because actually, yeah, we had all these measurements of different buses, but they were different, like at different times in the year, at different climate zones. So we couldn't really compare them one-to-one, as we have a huge impact of energy demand on the overall energy demand of the buses. So we needed a simulation of this part of the energy demand to correct it, to really have a fair comparison of the technologies. And we did this with the MATLAB model. So if there's any questions, I can tell also more, but for now, just want to go on and not telling more about this. But just one point, I think this is always really important if you do some kind of comparison, like the data input you have, this is really the important thing. And if you can't trust your data, it's really hard to do anything of scientific analysis on like the kind of technology you would like to choose. So anyway, on this, we did the comparison for the greenhouse gas emissions for these different concepts. And like for the upper left, you see the emissions in 2015. And this is calculated with the German average energy mix. So even with like the so-called zero emission buses, you see that there's a of greenhouse gases due to the use phase, which are basically the emissions of the power plants. And then what we did is, if you see more to the upper right corner, that we said, okay, we have these buses, but they are not just in use. I mean, if we take a decision about buying them now, they will be in use over the next 12 years. So the question really was like, what are the average emissions in the next 12 years? Kind of specific plans in Germany, how the ramp up of renewable energy will be in the next years. We could calculate here, like to give us good feeling about how the emissions will develop. And what we see is that then all of this technology will become significantly better than the today's, or like even the diesel buses of the future. Also, what we see is that still the emissions of the use phase will dominate the total emissions. Even like we have like a significant impact of the production of batteries, especially for the overnight charger here, the ONC. This is not so relevant for buses because they are used so heavily. They have such a high usage in their lifetime. So in total, it's really not so much. And what is really the big factor for the total greenhouse gas emissions is the greenhouse gas emissions of your grid, of your electricity mix. Then in the lower half, we did the same for buses in 2025. There we assumed some improvements for also the electricity mixes were getting better. And I think here just the differences between the conventional diesel bus and the new technologies will rise. So we really see that as far as we go, as better our electricity mix will become, as more mature the technology of electric buses will become, the environmental advantage will become higher. The other parameter we were doing a ranking of the different fuel concepts is the costs, and here we also looked at the total cost, like the life cycle costs, and to compare different type of costs, we chose the methodology of equivalent annual costs. So we calculated like the whole lifespan of investments, and then we put this into relation to what this will cost in 1 year of usage. And to have analysis including as much as possible, we just not look at the vehicles, we also look at the infrastructure, at the drivers, the energy costs, replacement costs, and also the maintenance to get cost per bus kilometer and also per line capacity. And here to say this is also like really Germany specific costs, especially for drivers and for energy. This will be really different in other parts of the world. Here are some of the results. This is just for vehicles. And as my colleague Dominik Räder said already, buses, which are here, the blue bar, are a lot less expensive for today. And like the battery electric or like all electric buses has much higher costs. Also, it's worth to mention here, these are costs which we took from literature, and it's not like actually prices. So this is always an interesting point when you actually procure buses, that the prices can vary a lot from the costs, depending on like which situation you have, like which is you can have like a good connection to the bus manufacturers, you have a lot of competition, you order a big fleet, so this is has big influences on the actual cost, but and this is more like, as I already said, like generic values. Anyway, as costs are highly fluid in these times, I think like if we look now for 2020, which is in between these two graphs, I think I can say that this is still kind of valid. Even if you say, or yeah, if you could look at that prices are normally like 10 or 20 or 30% higher than the actual costs. So yeah, I think we see this reflect the actual market kind of good. Maybe, well, besides, let's say this, the fuel cell, it doesn't, yeah, it didn't decrease in cost so much as we expected. So it's still pretty much on the level we see in 2015. So another important thing is the infrastructure, which is also really costly, in fact, if you introduce a new technology. So this is also a thing if you want to choose a technology for a whole net, then you have like these effects, like these networks effects, which are really necessary, so you can really make your infrastructure affordable in a way. So this is where just like some things we said for that line, and yeah, I think I always skip this to come more to the results. So these are the results, and I think this is interesting to mention that this is like the Y bar is the costs per year in line, and the X bar are the capacity. So this is not just like the one bus running at a line for a year, it is like the whole infrastructure, the drivers and everything. And it is also important to say, okay, this is just like buses running every 10 minutes, because like what you want most is transporting passengers. So the capacity is like what is interesting you in most of the cases. And what is an interesting thing about like the different bus technologies is that actually the same bus has different capacities or capacity restriction, even if it's the same size, because of mainly the weight of the battery. So what we see is that the overnight charger with the big battery has a lot less capacity per vehicle, which even like this an attractive option for lower capacity lines, but as higher the capacity demand is, this is getting a less attractive option. Yeah, what else we can see is that sure, the diesel bus is still like the most economic and even in Germany for 2025, but then there's a lot of mixed year outputs of this depending on which capacity you are looking, and but what you can still get out of this that are technologies which have higher infrastructure costs, like the opportunity charger or the emotion charger, are getting more economic viable if you look at higher capacity lines. Yeah, so this was the results of our study in 2016, and I really hope that you could learn something out of it, because like when Rohan was asking me, in the first thing I was like, oh, but you know, this is already like kind of some old data, but then I looked at actually like outcomes which are really recent, and they didn't tell so much different things, so I was still okay, yes, I can say something to it. So yeah, I'm happy to hear some of your questions.
Thank you so much for those very insightful presentations. I do realize that we are over time, so I hope you can stay with us for a few more minutes to answer some questions, if that's okay, Dominik and Fabian. Then we will jump right into the Q&A, for which I'm handing over to my colleague Rohan, who's been monitoring what the questions and answers are out there.
All right. Yeah, thank you very much, Lena. Thank you very much, Dominik and Fabian, for this insightful presentation. Yeah, personally, I have learned a lot from the topic which you just presented. And since we are already past our scheduled time, I'll just quickly run through the few interesting questions we have received. So the first question goes for Fabian. It says on slide 24, you mentioned that for production level LCA assessments, there are databases like EcoInvent which are being used, or which were used in your study. Does these database also provide data for developing countries? I think the question leads is the study was mainly done for the Europe, and if such study is supposed to be done for developing countries, maybe somewhere in Asia, then do you think those data are available from the data sources you used?
Yes, I really think this is comparable data, because anyway, so for the study we looked at, for example, batteries where the cells are manufactured in Asia, and then just the packaging were done in Germany. But like many of the really big factors for the mission are global supply chains, which will not be so different for Europe or any Asian country.
Thank you very much, Fabian. The next question is from Nyaga Kebuchi. The question is, are trolley buses still being produced, and how costly are they considered in comparison to battery electric buses?
Yeah, this was like one of the main questions we had when we started the study. It was also like this feeling, okay, but trolleybuses, this is like a technology which was developed like something like 200 years ago, and on the other hand, we have battery electric buses which are really new and state of the art. So how can we compare this two? I mean, this one is so outdated technology, and the others like this fancy new stuff. But in the end, it really like it's really comparable technologies, and yes, they are produced. I mean, they were and run in like really a lot of cities like during all like let's say all times since they developed. They're really huge fleets, especially in the former Soviet Republic and countries, like especially in Moscow, you have a really big trolley fleet, and but I mean, I don't know about Asia, but I think there are also some trolleybus fleets in Asia, and also there are some bus manufacturers which are still producing them. So the second part is about the costs. Yeah, for the time being, we were looking at. So this is the point. So I think, like, if you compare the costs, really you need to consider the infrastructure. You need to consider like the capacity you can really reach with that system, and like how many drivers you need, how many buses you need. So like from the today's perspective, I would say if you don't have any infrastructure and you don't plan something which has really high capacity demand, then the battery electric buses will like coming more in favor of you. But as more as you're looking into higher capacity, like for example, if you're planning bus rapid transit system, this could be really interesting technology. And then you really need to go into detail. And also what is interesting from this point of view, when we weren't looking at that the trolley buses you have, are in operation for sometimes 30 years, for 50 years. This is like kind of indestructible technology. And well, for battery buses, we don't know yet, but moreover, they will not have such a long lifespan. So this is also something to take into consideration.
Mm-hmm. Yeah, thank you, Fabian. Yes, and the point which you touched upon was, I guess, yes, there are few cities in Asia where trolley buses are being operated. One city which I could remember is the city of Kolkata in India. But yes, I'm not sure where they procure the buses from. And since you had already touched upon the BRT, the one question asked is, does the BRT projects, does it make sense to go for the conventional trolley buses in the BRT project, or with the in-motion charger buses? So which could be a better choice for a BRT project? Maybe if we consider just a flat surface, if we consider flat topography, which could be one suitable technology?
Well, I think, I mean, this really have to be looked more into detail, but if I look at how battery prices are developing, I think the motion charger is really getting a more viable option more and more, and there's less and less reason to consider the standard trolleybus, because like all things you can save, it's like for one thing, even if you say, okay, I still have the catenary lines during the whole line, but it's much easier if you don't have like all this catenary lines in the depot, which is like a really messy thing because their buses need to go in every direction, and this is hard to realize with this technology. And then it's much easier if you have some battery and there you can just move freely. And also it has another advantage, especially I think in developing countries, that you can somehow the peak energy demand on the net, it's not so high because you can kind of flatten it with your battery. If there's the bus is starting from the bus stop, it can taking some of the energy from the catenary, but also using some of the energy of the battery, and also it can recuperate, putting energy back into the battery when it's breaking. So overall, I would say if you see all these effects, the motion charging technology has really some advantages. But yeah, then you really need to look in details for a detailed analysis of the costs.
Okay, and yeah, the next question is from Luis Gerardo. He says, for the question is again for you, Fabian. Did you consider the cost of charging infrastructure in the graph which you showed on slide 29? So I think the graph which Luis meant is the comparison of different fuel concepts, LCA 2025, the final chart, I guess.
Chart, yeah. Yeah. So here no costs for infrastructure explicit in this. This is really the whole cost of set up the line and running the line, including the energy cost, the driver, the infrastructure, and the vehicles. Yeah, is there a specific question for the infrastructure costs?
Yes, so I guess what Luis meant was while calculating maybe the ONC or maybe the OC category life cycle costs, did you also consider the charging infrastructure costs, so the hardware costs?
Yes, we considered this. So we considered the whole infrastructure system you need, for the opportunity high power charging point. In most contexts, you need a known substation for this high power charging point, like this. So yeah, when this was also the generic use case. So if you have a specific city where you have already some tram line, you could use a substation from the tram line. This could also be really different and the cost could be much lower. But on the other hand, if you have for example, I worked in Kigali in Rwanda for some time, and there you would put massive improvements in the whole electricity net if you would like to have some opportunity charger with this charging, let's say, with 500 megawatts for something like 2 minutes or so. I mean, it wouldn't be possible for the general electric net just like this.
Okay, and the next question is directed towards you, Dominik. The question is on slide number 12. You showed two charts showing Clean Vehicles Directive 2 phases. That's a obligation for the member states to introduce clean buses and zero emission buses. So what happens if EU member states doesn't achieve the CVD set quotas on public procurement?
So they have to pay for penalties. So they have to pay penalties if they don't achieve these quotas. Yeah, but I don't know how much it is. If it's per share, I'd have to look into the details and double check that.
All right, maybe we can send the final answers maybe in the wrap-up email, which we may send to all the participants. And last, but yeah, the last question is again directed towards Fabian, and it says on slide number 25, apart from the increased RE energy, which could be set for use, what are the main factors which are bringing down GHG emission for different fuel concepts from 2015 to 2025, especially in the use space?
Yes, so reduction in energy usage. So the concepts are getting more efficient, but really the is that a lot of high emitting power plants in Germany are going out of the net and are replaced by renewable energy. So yeah, I think this is really one of the core messages from this, that if you want to have like a big advantage from electric buses from a GHG perspective, you need a high share of renewable energies.
Mm-hmm. Okay, yeah, so that's it from my side, and I think yeah, I would like to hand it over back to Lena.
Thank you so much, Rohan, and thank you to all the participants to these very in-depth questions. I'm very excited. But of course, a big thank you to our speakers today for taking the time and even the extended time to present us their ideas and their work, and then being available for the Q&A session. Don't forget to follow us on the different channels so that you get updated about the next episode of the Charging Station when it's coming out. And let us know if you have any feedback on this session today or any additional questions that we didn't address, and we will be happy to do a follow-up. But for today, I wish you all a good rest of the day or night, wherever you are. And thank you for tuning in and joining us today.